Hello folks, this is Shardul Gavande from Ace Knowledge. So today in this video we are going to see practical number 5b, which is to generate a sine wave on oscilloscope with the help of lookup table stored in data area of 8051. So now here we have to generate a sine wave and we have to create a lookup table stored in the data. So this lookup table basically means we have to create an array. So let us start with our practical and let us create a project first. Keel Vision project. I'll give the name as sine wave. Select our microcontroller 8089C51 and so let us understand first how exactly we have to generate this wave. So a sine wave, which means a wave like this. Okay, so now suppose this is our graph. This is for your understanding purpose. So we have here 0, then 16, 32, 64, 128, so on till 255. Now suppose if I select this point as 128 and from here I have to draw a sine wave. So I need to go right to the top, then I need to come to the down till 0, then again I have to go to the top and come down and so on. So this is how I will generate a sine wave, right? So the part which we have to enter in our code is still this part. So let me take another color. So from here, starting from 128, going to 255, then coming from 255 down, back again to 0, and from 0 again till 128. So traversing from year to year, considering all the numbers whichever come in this way, we have to put it in an array and make it as a lookup table. And the further part will go in the for loop. Okay, so let us see how we can code it. Let's create a new file over here and include first the header file reg51.h. So here we have one more header file as hash include int rins dot h. So this int rins dot h is nothing but an inserted inline method to be called. So this is also one of the header file. I'll tell you why we are including this header file in our program. So let's create our main method first, and inside our main method we'll declare one unsigned variable I, and we have to declare and create an array, right? So another would be unsigned int. Let's give the name of that array as wave values, and we create an array over here. This is the empty array. So we have to enter the values in this array. So the values would be right from start point of the wave is 128. So 128, 192, 224, 240, 255, so on. We'll take all these values and come back again over here. So all these values right from bottom to top and top to bottom again, this total numbers would be 16. So we have here array size would be 16, and now let's go on inserting. So first starting from 128, so this 128, 192, 224, 240, 255. So 128, then 192, then we have 224, then we have 255. So once we reach at the top, we have to come again to the down since we want a sine wave. So after 255, again 240, 224, 192, 128. So we'll come till 128 back again. So 240, then we have 224, then we have 192, then 128. Okay. So now from here again we have to go to the extreme bottom side. So 128, after 128 we have what, 64, then we have 32, then we have 16, and then we have 0. to the bottom, and from here again a slightly little we have to come upwards. So again from 0 we have, after 0 16, after 0 comma we have 16, then 32 and 64. So this curve part, this I will highlight it. So this curve part from 0 till here, okay, so this is nothing but 16, 32, 64. So we won't write 128 again because it will go into the loop part. So these are total 16 in number. Now next we have to create a while loop. So while 1, and this, in this while loop we will have our for loop. So for I equal to 0, then I less than 16, the total size of an array, and I plus plus. Okay, so inside this for loop we have again the value of p1, port 1, in which the I value will traverse through all these numbers, and so a wave pattern would be created. So I value would traverse through this array, so the name of the array is wave value. So p1 is equal to wave value, and in box bracket we'll pass the variable as I, semicolon. And next we need to call some predefined inline function as NOP. So this NOP is nothing but no operation. So the work of delay till now what we have seen, which is giving some time interval, so NOP does the same work as that of delay, and it is used to generate one instruction cycle. Okay, so NOP. So we will call this particular function again and again, 2, 3, 4, 5, 6, and yes, we are done with our code. Let us save it. I'll give the name as Sine. Save. Let us add it to our source group. Add to existing file. Sine. Add. Type as C source file. OK. Close. Make sure it gets added over here. And now right click on target, options for target, set the frequency 11.0592, select OK, right click over here and build target. So it says 0 errors and 0 warnings, which means our code is perfectly right. So this NOP, in order to use this function NOP, you need to include this header file intrins.h. Okay, so let us debug, stop debugging. Okay, and let us open our logical analyzer window over here. Let's bring it in between and debug and run. Oops, we forgot to make the setup, so let us stop again, make a setup over here, add the port P1 over here. So once you add the port P1 over here, you can see the display type analog and all the necessary properties. Close. And now let us again run our file. So let us stop again and check in our code. Stop debugging, and over here it is showing some reference made to unresolved external. Okay, so we are missing underscore over here also for no operation function. And now let us save again and build our target. Okay, so now the error is gone. It was a warning. Debug, stop debugging. Okay, logical analyzer, and let us run it now. So yes, we got the output now. If you zoom in, you can see the sine wave generated. So the missing part was just this underscore after NOP. So underscore should be before NOP as well as after NOP. Okay, so yes, we have successfully generated a sine wave. So that's it from this video. Thank you so much for watching, and don't forget to subscribe.